Welcome to the introductory session on biomechanics. Let us have a glimpse of what are all the introductory topics in Unit 1, that is the Introduction to Mechanics, which includes principles of mechanics, Newton's laws, linear kinetics of human movement, angular kinetics, linear kinematics of human movement, angular kinematics, equilibrium and human movement. Why do some golfers slice the ball? How can workers avoid developing low back pain? What cues can a physical education teacher provide to help students learn the underhand volleyball serve? Why do some elderly individuals tend to fall? Although the answer to these questions may be rooted in physiological, psychological, or sociological issues, the problems identified are all biomechanical in nature. This unit is a foundation for identifying, analyzing, and solving problems related to biomechanics of human movement. The term biomechanics combines the prefix bio, meaning life, with the field of mechanics, which is the study of action of forces. Within the fields of kinesiology and exercise science, the living organism most commonly of interest is the human body. The forces studied include both the internal forces produced by the muscles and external forces that act on the body. So now let us define the term biomechanics. Biomechanics has been identified as the study of the movement of living things using the science of mechanics. Biomechanics provides conceptual and mathematical tools that are necessary for understanding how living things move and how kinesiology professionals might improve movement or make movement safer. Biomechanics use the tools of mechanics, that is, the branch of physics involving analysis of the actions of forces to study the anatomical and functional aspects of living organisms. Static and dynamics are two major sub-branches of mechanics. Coming to the applications, two major applications of biomechanics are to improve the human movement and to provide treatment or prevention of injury. The key terms which we must know for learning biomechanics are mechanics, statics, dynamics, kinematics, kinetics, kinesiology, sports medicine. Here is a list of some of the quantities that are in scalar and vector and their units. For example, mass or weight in kilogram, speed, velocity in mph, kinetic energy, momentum, kinetic energy in joules, momentum kilogram meter per second. Coming into the Newton's laws of motion, Sir Isaac Newton discovered many fundamental relationships that forms the foundation for the field of modern mechanics. The first law of Newton, it is called the law of inertia. It states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. In other words, a motionless object will remain motionless unless there is a net force acting on it. Coming to the second law, which is called the law of acceleration, this law is an expression of the interrelationships among force, mass, and acceleration. It states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. When a ball is thrown, kicked, or struck with an implement, it tends to travel in the direction of the line of action of the applied force. The third law is called the law of reaction, which states that for every action, there is an equal and opposite reaction. When a person leans with a hand against a rigid wall, the wall pushes back on the hand with a force that is equal and opposite to that exerted by the hand on the wall. During gait, every contact of a foot with the floor or ground generates an upward reaction force. With this glimpse, I shall conclude this session. We shall continue with few more basic principles on biomechanics in the next session. Thank you.